My name is Dr.P. C.Patel, working previously at Anand Agriculture University and Barley University. The today topic is reclamation of saline and alkaline soil. So you know that it is a problematic soil and the crop productivity is low as compared to normal soil. So why the crop productivity is low? Because the nutrients are present in the soil, but it is not available to the plant due to constraint of soil like high pH, high salt, then high sodium content in soil. So we have to reclaim first saline soil. In saline soil, there will be soluble salts of calcium, magnesium, potassium, sulfate, carbonate, and chlorides. The pH is about 8.5, but electric conductivity is more than 4 millimoles per centimeter. So there are three methods of the reclamation: physical, chemical, and biological. So first we see the physical reclamation methods. So among three methods, scraping, flushing, and leaching. So scraping means the salt of accumulated on the surface can be removed by mechanical means cultivating, plowing, and so on. Then flushing, washing of surface salt by flushing water. Then leaching with good quality water, that is either irrigation or rainwater is used for the leaching purpose of the salt. Then drainage. You know that drainage is very, very important for the root growth. If drainage is poor, then there will be poor aeration to the roots and there will be less uptake of the nutrients by the roots and the growth of the crop is stunted or less. So poor drainage condition lead to accumulation of rainwater in a low-lying area during rainy season. If it is not drained out properly, the groundwater table is raised to less than 2 meters within 5 to 10 years and result accumulation of soil due to evaporation from the surface. So what happened? The water is stagnant on the ground, then water is evaporated, then the salt remain on the surface. So that salt is accumulated on the surface of this soil and which will hinder the growth of the plant. In general, the critical depth of water table ranges between 1.5 to 3 meters to check the salinization. So drainage is necessary to prevent salinization. So if you are not prevent the drainage, so there will be necessary to prevent the salinization. So drainage is required so that there will be no further salinization. Salinization means more accumulation of salt on the surface soil. And you know that we are observing the saline and alkaline soil in the low rainfall area, like Rajasthan and Kutch area. So what happened in that area, the rainfall is low. So the salt has been not washed out due to rainwater because rainfall is low. So slowly and slowly the water is evaporated and salt accumulates on the soil surface and the crop productivity decline. Then chemical analysis or the chemical method for salt affected soil. So first we have said physical, then say the chemicals. So chemicals methods, nutrient management. So in nutrient management, nitrogen, symbiotic nitrogen fixation, nitrification are inhibited. Use of nitrate fertilizer rather than ammonium nitrogen in split application is better in saline soil. You know that when we are apply the urea or ammonium sulfate in the soil, then it converted into ammonia, then nitrite, nitrate, and plant will take the nitrogen in form of nitrogen and ammonical form. But when there is a problem of the high soil pH and more concentration of the salt, then there will be poor aeration. So the growth of the microorganism will be reduced, and the process of nitrification will not place. And in absence of the aeration, the denitrification process take place and nitrogen has been escaped in the atmosphere. Then phosphorus. Higher application of phosphorus fertilizer helps in increase the yield. So I told that the nutrients are present in the soil, but it is not available to the plant due to constraint of the soil. Therefore, we have to apply the phosphatic fertilizer in the soil so that phosphorus is available to the plant and your crop will has been increased. Potassium and micronutrient, higher application of this fertilizer help increase the yield. So generally you will find that in problematic soil, saline, alkaline soil, you will find the deficiency of the zinc and iron. They are present in soil, but it is not available. Therefore, when we are applying the zinc sulfate or ferrous sulfate at the rate of 25 or 50 kg zinc sulfate or ferrous sulfate per hectare respectively, then we can increase the crop productivity. Then third one, biological method for salt affected soil. So organic matter application, it helps to increase water holding capacity of the soil and decrease the conductivity of the soil saturation. Then fallowing, keep the land fallow during the monsoon season so that salt accumulated during the winter season are leached out, making the soil fit to grow next crop. So you know that in a Barley area in saline alkali soil, during the monsoon season, they stagnate the water and that salt has been leaked down and they are grow the wheat and late cotton crop in that area. Then mulching. You know that when we cover the soil with the help of the plastic mulch or grasses or crop stubbles, then it controls evaporation and salinity buildup. Then agronomic practices for salt affected soil. So saline soil. So choice of crops and cropping system. So here you can see that relative tolerance of crop to salinity. So date palm, barley, sugar beet, spinach, rapeseed, and cotton are these tolerant crop to saline soil. Then semi-tolerant, pomegranate, wheat, oat, rice, sorghum, maize, and sunflower. So you can see that pomegranate, wheat, then rice, all these are grown successively in a saline soil. So in Tarapur area and in Bal area, they grow the wheat and rice and also sorghum. Then sensitive crop, you can't grow this crop sensitive like citrus, cowpea, ground, peas, groundnut, lentil, and green gram because they are all sensitive crops. So Bhalia wheat and barley salt tolerant cereal crop. I am located at Anam and from about 70 to 80 kilometers, there will be a Bhal area. So in Bhal area, they grow the Bhalia wheat. So I told that it is a salt resistant crop. Similarly, barley is also salt resistant crops. So Bhalia crops, they grown, Bhalia wheat, they grown in a winter season. So Bhalia wheat is grown in saline area of Bal in Gujarat, India, more price, superior quality export in foreign countries. So you remember that when you grow the crops in a saline soil or alkaline soil, then the crop productivity is very low, 1,000–1,500 kg per hectare, due to smaller size of the fruits, either tomato or brinjal and so on. Similarly, the wheat is also low production, but the quality of the wheat, then tomato, then guava are superior because there will be more concentration of salt. I will give one example. Suppose you have normal soil, then you are getting 5,000 kg per hectare wheat crop. But when you have the problematic soils like saline alkali, then you grow the Bhalia wheat or other wheat, then you are getting only 1,000 to 1,500 kg per hectare. Means here, in more yield than the chemical constituents or nutrient are diluted. So the taste of that wheat is not good as Bhalia wheat. Here, the concentration of the nutrients is more in Bhalia wheat as compared to wheat grown in normal soil. So here you know that the price of the Bhalia wheat is very great. And the India is exporting the Bhalia wheat to the foreign country. So suppose the normal wheat is about 20-25 rupees per kg. Here, the Bhalia wheat is about 50-75 rupees per kg. So when the production is low, but we are getting the more price due to higher price of the wheat crop. So I told that barley is also the salt tolerant crop. And you know that in India, Karnal, previously the soil of the Karnal is a better soil. But what happened? They are used the excessive water of irrigation. Ganga rivers and Brahmaputra river, they are using plenty of water to the rice and wheat, and they have deteriorated the soil, and now the soil becomes saline and alkali soil. So they are growing the barley crop and wheat crop and also rice crop. You know that the rice crop can be grown in saline soil because the rice crop require the standing water. And when you fill up this soil standing water, then whatever the salt present in the soil that has been diluted and rice crop has been grown successively in that area, particularly in saline or alkaline soil. Then I told that sorghum and bajra are also salt tolerant crop. So you know that in Rajasthan, bajra has been grown, sorghum has been grown, similarly in Kutch area. So you remember that sorghum is a versatile crop. You can grow in any type of soil. It is a drought resistant and it requires lesser irrigation water as compared to other crops. So sorghum and bajra you can grow, but you can't grow the maize crop or corn crop in saline alkaline soil. Otherwise, you will get the low crop productivity. You all can also grow the soybean crop in that area. Then we will talk about the horticulture crops in saline area. So mandarin, then pomegranate, and sweet orange has also been grown in saline soils. And you know that in Kutch area, the farmers are growing the pomegranate and they are fetching very, very more income from that area because the soil is saline, then water is also saline. So the quality of the pomegranate is superior and they are exporting to the foreign country. Similarly, I told that it is a pomegranate you can grow in saline soil. Similarly, papaya also we can grow in a saline soil. Horticulture crop also we can grow in saline soil, mango, banana and grapes. In Nasik area in India, you know that Nasik, the area grown grapes in more area. Similarly, banana and mango, they are growing, although they have this saline water. But saline water is not more dangerous as compared to the, or saline soil is not more problematic as compared to the alkaline soil. In saline soil, the aeration is good, but in alkaline soil, there will be poor aeration. So the crop productivity is very, very low. And in some time, you will not find even the growth of any crop in highly alkaline soil. Then causes of poor productivity of sodic soil. So I told that sodic soil or alkali soil are same. So there will be high content of sodium ion. So exchangeable coupled with the pH having toxic level on roots, and roots are damaged under active causes, the root and soil organic matter present in the soil get dissolved. Then I told that there will be poor aeration in sodic soil or alkaline soil is another important cause of poor productivity of soil. Root cannot get sufficient oxygen from the soil atmosphere. Carbon dioxide of soil atom is very high and oxygen is low. So root cannot respire and resulted in poor productivity. We are observing that during the corona COVID-19, there will be attack on the lungs and the human being will not take the oxygen properly and sometimes they will die. Similarly, here in plant also root cannot get sufficient oxygen from soil because there will be waterlogged condition in a sodic soil because the particles are dispersed, that is deep flocculation. So here deep flocculation and swelling of clay due to high exchangeable sodium, this cause the tillage operation very difficult, so cause the poor productivity. So sodic or alkaline soil are not suitable for higher crop production. So how to manage the alkali soil? So gypsum application in upper 15 centimeter soil depth. Nutrient management required 25% more nitrogen. So you remember that when you have the problematic soil, that is alkali soil or saline, sodic soil, then you have to apply 25% more fertilizer. Suppose you are growing the rice crop, then 100 kg nitrogen, 50 kg phosphorus, and 50 kg potassium. Then you have to apply 25% more nitrogen, that is 62.5, then 50 kg phosphorus, so you have to add 25% more. So suppose 100 kg, then you have to apply 125, then 62.5 phosphorus, then 62.5 potassium per hectare. But in normal course, 150 is sufficient per hectare. Then low infiltration rate, I told that when you apply the irrigation water or rain water, then that water will not go downward due to dispersion of the soil particle, that is due to deep flocculation. Then high evaporation lead to secondary salinization. You know that in arid region, I told that in arid region, Rajasthan, then Kutch, then some part of the Madhya Pradesh, you will find the saline alkali soil. So we will not find the more tree and vegetation. So there will be more erosion due to wind erosion. And you will find the sand dunes in Jaisalmer and other parts of the Rajasthan. Then sodic condition can be improved through the use of certain amendment. I told that gypsum and sulfuric acid. Then crop grown on fertile soil may see more salt than those grown with adequate fertility. Application of farmyard manure, mean cow dung or buffalo dung, increase solubility of the applied gypsum and hasten the reclamation processes. Using green manure crop like suspenia, reclaim the alkali soil. Kernel grass, road grass have been found better for alkali soil and it is a soil tolerant crops. So in Karnal area, I talked about the Karnal and DRI, UP, Haryana. So they can grow the tolerant grasses like Karnal grass and road grass because they are salt resistant. Then alkali soil. So we have seen nutrient management saline soil. Similarly, here we have say the nutrient management in alkali soil. So nitrogen. Application of ammonium sulfate is better than urea and calcium ammonium nitrate. Why ammonium sulfate is better? Because when you are add the ammonium sulfate in soil, then it reduces the soil pH. The soil pH of the alkali soil is greater than 8.5, so we have to reduce. And you remember that when the soil pH is between 6.5 to 7.5 is a ideal soil pH for availability of the maximum nutrient to the plant. But when the pH is increased from 8.5 then the nutrient present in soil, but it is not available to the plants. Therefore, we have to add ammonium sulfate in alkali soil. So the pH has been reduced and the more nutrients available to the plant, and we are getting the better growth of the plant. Then phosphorus. At high pH ability of phosphorus is more and hence no response to applied fertilizer in early phase of reclamation, but gradually phosphorus ability decreases. So if it is exception when there is a more pH greater than 8.5, then phosphorus ability is more. So when we are apply the phosphatic fertilizer in a alkali soil or sodic soil, then we are not getting the response. But after some time, when the plant growth attain, then you are apply the phosphorus, then you are getting the response. Then potassium uptake decreased due to high sodium and deficiency of calcium in alkali soil. So you know that there will be competition of the nutrient in soil media. So I told that in alkali soil or sodic soil, the sodium clay is dominant. So what happened? It will not allow to the potassium and calcium for the uptake because sodium is greater. So when there is a sodium is greater, then it will not allow the potassium, then zinc, iron, and calcium. And therefore, you will observe the deficiency of the potassium, calcium, zinc, iron, boron, and so on in alkali soil. Then Suspenia and Bersim grow in sodic alkali soil. You know that you can grow the lucerne crop also grown in sodic soil. So the Bersim crop is a forage crop and it will feed to the animals. Suspenia crop is also reclaim the soil. So you can grow successfully because both these crops are alkali resistant crops. Lucerne crop is also grown because I told that lucerne is grown in Kutch area and the soil of the Kutch is saline alkali. So the lucerne crop is grown successfully. Then sodic soil. So puddling in lowland rice it is carried out mainly to maintain the infiltration rate to show the water and to control the weeds. So why we are doing the puddling operation in a rice field, particularly in lowland rice, because we want what a rice crop want the standing water. So we make the soil hard with the puddler operation. Either now it is tractor down, puddler operation is there, cultivator is there, so you can control. And when there is a water present in the lowland area, then you will also not find the weeds. And rice crop require the maximum water as compared to other crops. Then age of seedling, tolerance of the crop increase with age. So generally I was previously service in 1974 to 1977 at main rice dissertation, Navagam, Taluku Matar, district Ahmedabad. So we have recommended that 21 to 30 days age of the seedling of the rice is better for higher crop production. But in sodic soil, we have to grow this seedling of 35-40 days old. Why? Because you know that when the seedling is young, then it is not tolerate to sodic soil. But when it is progressive, then it tolerates the sodic condition or alkali condition. I will give another example to you that when the child is small, then it is very susceptible. But when it grows, then it creates the power of the resistance. So similarly here, it is true for the rice seedling. Then higher plant population and closer spacing is essential. So why higher plant population and closer spacing is essential? Because you know that when there is a more salt present in the sodic soil, then there will be mortality of the plant. And closer spacing means you have to grow the more plant of the rice or other crops. So when the plant have mortality, then there will be no gap filling and you are getting the higher crop production. But suppose you grow the distance like normal soil, then there will be mortality. I told that due to sodic soil, then there will be gap filling and you are getting the low crop production. Then another thing you remember that growing the crop the side of the field. So here you can see that here we have to grow the ridge, side of the ridge, so that here the soil concentration is low as compared to the furrow. That is why we have to grow on the ridges of the crop. Then equivalent quantities of some common amendment for sodic soil reclamation. Amendments means it is fertilizers, so which reclaim the sodic soil. So gypsum, then calcium chloride, sulfuric acid, iron sulfate, ammonium sulfate, sulfur, pyrite, and so on. So among these, iron sulfate and aluminum sulfate quantity more, but gypsum is generally used in agriculture because it is cheaper and it is a byproduct of the GSFC, GNSF fertilizer factory. So they have the problem of the disposal. So government of India has started to give very cheap rate to the farmers. And government also gave the railway transport on subsidize to the farmer so they can use the gypsum for reclamation of the soil. Generally 2 to 3 tons gypsum is required, but it depends upon the sodium present or salt present in a soil. Here you can see that it is a wheat crop. So here gypsum is not applied on the left side and on right side we have applied the gypsum. So you can see here the improved crop growth in a wheat crop on a sodic soil with gypsum applied at the rate of 5 ton hectare. So it depends, I told that it depends, the gypsum application depends on the sodicity of the soil. So here they have applied 5 ton and here they have not applied the gypsum, although the soil is sodic soil. So you can find the clear-cut difference in right side, figure 2, the growth of the wheat is better as compared to the figure V1 left side. Then green manure crops. To improve the saline soil or alkali soil, we must have to add more organic matter in soil. So we have added the farmyard manure, then compost and poultry manure. Then we can also do the green manuring crops like dhencha. Why I select dhencha crop? Because it is a salt resistant crops. You can't grow the sun hemp. So sun hemp can be grown in normal soil, but here you can select a sun hemp crop in problematic soil, alkali soil or sodic soil. It will not germinate properly. So dhencha is salt resistant crop, and here you can see the growth. And in cotton, they have made the green manuring. So here is a cotton crop, and in between cotton, that is intercrop, they grow the dhencha. Then when it attains the height of 2 feet, 3 feet, after 50 days, then it will be incorporated in the soil with the plows or tractors. Then it converted into organic matter. So the cotton crop is benefited and we have required lesser nitrogenous fertilizers. So we can save the nitrogen. Then classification of saline water. You know that when water, underground water is not pure everywhere. Why? Because you know that near the seashore, there will be intrusion of the sea water in a soil. 100 kilometer or 200 kilometer, that water has been intrusion. pass underground water. So it will mix with the normal water and the water becomes saline. And when you withdraw the water and apply to the plant, agriculture crops, then your soil becomes saline. And again, you are not taking care, then it converted to saline alkaline. Again, you are not taking care, then it is alkaline or sodic soil. So the crop productivity of saline soil, the 3000 kg, suppose you take rice or wheat, but when it is converted into saline alkali, then it convert the yield is expected 2000 kg per hectare. But when it converted into alkali soil or sodic soil, then you are getting the crop productivity only 1000 kg, or in extreme case, you are only 500 kg, or sometime will not germinated the plant. So here different classes are there, non-saline, slightly saline. Then brine, you know that seawater, there will be salt concentration 35,000 milligram per liter. So as the salt concentration is increasing, the crop productivity has been declined. And you know that there will be direct relation. Electric conductivity has also been increasing. So in normal soil, then there will be only 0.7% Simon per meter salt. Then salt concentration less than 500. Then slightly saline, then it increasing. In irrigation water, I will give one example here. Some farmers are believe that irrigation water is good. But in irrigation water, 500 to 1500 milligram per liter salt. And you take the winter crop and summer crop. And in some time, when there is a erratic rainfall in monsoon season, then you also apply the irrigation water with canal water, tube well water, or well water, or tank water. So what happened? Suppose you are applying the irrigation to the wheat crop, suppose 7 irrigation. In summer, you grow the sorghum crop or corn, then you are giving again 5-10 irrigation. So totally, suppose you are giving 15 irrigation or 20 irrigation per year. So after 10 years, you are giving the 150 or 200 irrigation water. So irrigation. So what happened? That salt accumulated on the soil surface. So farmer told that why the crop productivity decline as the year passing. So the main reason is there. Every year salt concentration has been increased on the soil surface and resulted the crop productivity has been declined. So it is a classes low, medium, high. So it is a classes of the water. Suppose we have this C4 and S4 water, underground water, then that water has not been used for agriculture because it contains high sodium content as well as high salinity content. So quality of irrigation is very important. So total dissolved solid less than 1000 milligram per liter, then total soluble salt. So it is a different classes, C1, C2, C4. Then it is a depend on the basis of the sodium. It is S1, S2, S3, 4. So I told that S4 and C4. That water is not suitable, means unsuitable for agriculture purpose. Then residual sodium carbonate is also important. Residual sodium carbonate means how much concentration of the carbonate and bicarbonate present as compared to the calcium and magnesium. So the amount of the bicarbonate and carbonate is greater than calcium and magnesium, then there will be a problem. So what is the problem? So high concentration of bicarbonate and carbonate ion in irrigation water can induce precipitation of calcium and magnesium ion to form calcium and magnesium carbonate, which have low solubility. So what happens? The calcium and magnesium present in there, so that will be precipitation due to the more carbonate or more bicarbonate. So calcium carbonate, calcium bicarbonate, magnesium carbonate, magnesium bicarbonate. So which have low solubility. So when there will be low solubility, then calcium and magnesium will not available to the plant, although it is present in the soil. So the precipitation of calcium and magnesium allows sodium ion to dominate. So Calcium and magnesium ion present in soil that will be precipitated in the soil. So sodium ion is also more and it is dominant in the soil and thus increase the sodium hazard associated with the irrigation water. So sodium is very, very harmful to the plant. You know that when the human being have the more sodium, then there will be problem of the blood pressure and there will be suspects of the attack. Similarly, when the soil contains more sodium, then the crop productivity is very, very low. So sodium present in soil as well as irrigation water, it is very, very harmful. And therefore, the crop productivity is very, very low. So irrigation management, so frequency and timing, frequent light irrigation increase soil concentration in topsoil should be avoided. So don't give frequent irrigation, light irrigation frequently. Otherwise, the soil concentration comes on a topsoil or surface soil. Then high rainfall and heavy irrigation will remove salt from within a root zone. You know that I told that in Rajasthan there will be low rainfall, so salt has been accumulated. But the other parts like Himachal Pradesh, then Uttar Pradesh, the rainfall is high. So what happened there, the basic material has been washed out and their soil become acidic. So in high rainfall area, there will be problem of the acidic soil. Where low rainfall area, then there will be a problem of saline and alkaline soil. Then watering during hot dry condition increase evaporation and it increase concentration of soil. So suppose you are located in Rajasthan, you grow the crops in summer season, then you apply the irrigation, then high rate of evaporation, and there will be increase of the concentration of salt in the soil, and your crop productivity is low. Then drip irrigation, you know that government of Gujarat and India gives the subsidy about 50 to 70% to the farmers. So drip irrigation, that is in Gujarat, it is called Tapak Paddhati. Drip irrigation can reduce the effect of salinity by maintaining continuously moist soil around plant root and providing steady leaching of soil to edge of the wetted zone. So what happened to the drip irrigation? Soil become wet continuously, so there will be not increasing the salt concentration in a soil, so plant growth is better. Sprinkler irrigated crops are predominantly subject to additional damage caused by salt uptake into the leaves and burn from spray contact with leaf. Suppose you are located in Rajasthan, then your soil, your water is saline soil and you are spray or you are using the sprinkler irrigation in a wheat crop, other crops, then there will be a salt damage to the leaves and sometimes burning of the leaves and your yield has been decreased. So last one lies the saline water you put on the soil, it leaves behind the salt. Good mulch under the crop help reduce surface evaporation, maintain moisture near the soil surface and lessen the build-up soil salinity. So what happened? Here, plastic mulch is there. So what happened there? It reduced the evaporation. So whatever the moisture present below the plastic that remain, the evaporation rate is decreased. So the soil become wet. So when the soil become wet, then the concentration of the salt has been increasing. So mulch has been advantageous. So if plastic mulch is not available, then you can crop residue use, then straw has been used. But you know that nowadays I have taken this slide from the Bombay. One party prepared the biodegradable plastic mulching in tomato. So what they are doing, they have prepared the biodegradable plastic from the potato, and when you are apply using this biodegradable plastic, then it remain in the soil for 3 to 4 months, then purpose will solve. Then after that, that plastic has been decomposed in a soil, and it also helped it converted into manure. Whatever the fertility or nutrients are present that will be added in soil, so it also increase the fertility of the soil. So we should have to use biodegradable plastic mulching rather than use a plastic mulch. So thanks for listening to me.